Even you can share your screen and so guys, welcome to Network Kings, and it's a new program that we are starting for machine learning. So Manikant is the trainer who's gonna deliver this entire program, and this is our first batch. We are announcing that yes, we are starting. So even the price is also very lucrative based on the student interest basically. So yeah, Manikant, over to you. We'll start with the introduction. I'll disclose the price after the session.
Sure, Gaurav. Thank you. Thank you. Hi, everyone, guys. Good evening, good afternoon, good morning, depending on where you're watching this from and when you're watching. So my name is Manikant, and welcome to this session. So we are going to start at Networking. So we're going to start a wonderful course of data science, AI, machine learning, and all of these areas. So today I will be giving you a very broad, high-level overview understanding about artificial intelligence, data science, machine learning, all of these things. Let me give a small introduction about myself, and then quickly I will jump into the starting the session. So my name is Manikant Kandukuri, and I have overall 10 years of experience in the industry. I've done my bachelor's from BITS Pilani in 2011. So I would say in the overall 10 years, 9 years plus has been in the data science and machine learning industry, where I applied different machine learning models in Python, Java, and also in NLP side, working at different service-based companies and product-based companies. And recently, I got the opportunity to work in the generative AI space, particularly GPT-based, GPT-powered LLM model. I'm just implementing that to work on a wonderful use case. So this is just a small introduction about myself. And apart from my regular work experience, I also do enjoy teaching a lot. So I have delivered a lot of sessions before at IIT and a few other institutes. Now, let me quickly start the session for today. Let me share the screen. Okay. And I'm going to just do mirror image of the iPad. Just give me a second, guys. Okay, so I hope you guys are able to see a whiteboard sort of a thing here, and I'll be explaining few concepts in this, and also sometimes I'll go to slides or programming, coding environment and stuff like that, depending upon what I'm going to discuss. Now, the very first thing that I want to discuss about is what are the different skills required for one to be a good data scientist, right? Or a good machine learning engineer or an AI engineer. And I will be explaining about similarities and differences between these designations, right? Between these designations and also this roles and responsibilities, similarities and differences I'll be explaining between these, among these. We also have data analyst, right? So we need to understand similarities and differences among all of these designations. That also I will explain. First point that I often get is what does it take for one to become a data scientist? What does it take for one to get a job in the industry, begin a career in data science? You may have a background in something else, maybe mechanical engineering or maybe social studies, arts, history, computer science, electronics, anything. That's totally fine. You can begin your career in data science, irrespective of your background, provided you have these skills. What are those skills is what I'm going to discuss. That's the first thing that I'm going to discuss. Second point that I want to discuss is about, often you might have heard these terms AI, deep learning, data science, data analytics, machine learning, NLP, computer vision, robotics, right? What are all these? Are all of these the same thing? Are there any differences? If there are any differences, what are the differences? What is the difference between artificial intelligence and data science? Are there any similarities? If there are any similarities, what are the similarities? If one is working as a data analyst, what are the roles and responsibilities of that person? If one is working as a data scientist, Then what are the roles and responsibilities? Does a data scientist have more roles and responsibilities? Does he require more skills than a data analyst? All those things we have to understand. So this is the second thing that I will be discussing. Okay. Now let me start with this first thing. And when I explain this list of all the skills, it is common for all of these. I would say common for data scientist, machine learning engineer, NLP engineer, and AI engineer. You can ignore data analyst position for a while because in general, data analyst position doesn't require too much of mathematical understanding or too much of coding or too much of problem solving roles and responsibilities, or not that much compared to other designations. Okay. Now let me begin with the skills in general that are required for one to enter into data science or become a good data scientist or a good machine learning engineer or NLP scientist. Okay. In some cases, even AI engineer. So for these, I would be explaining the list of skills required. So this is my personal categorization. There is no such categorization exists in any book or any given by any professor, but this is just to simplify. I have divided the skills into 4 pillars. Okay, imagine that there are 4 pillars, and when all of the 4 pillars are strong, that means your base is strong, right? And on top of this base, you can construct as many floors as you want, or you can have the advanced concepts here, right? So this is like the ground floor or the base. There are 4 pillars. Imagine a building. For a building to be stable, the 4 pillars has to be very strong, right? At the foundational level, the ground level, base or foundational, right? So I'm going to tell what are those 4 pillars for a data scientist or machine learning engineer, NLP scientist or AI engineer in general. The first one is math or maths, basic, but I don't want you to be exceptionally good in maths. If you're already there, then wonderful, terrific. If you enjoy math, right, you like problem solving, you like puzzles, right, you like to you enjoy math, you like to think about different ways to solve a problem, creative ways to solve a problem, then you're already halfway there, because this is completely math driven. It's the concepts in the machine learning or models you will learn has a strong fundamental mathematical background, but you don't have to be exceptionally good at it. If you're exceptionally good, then wonderful, and you don't need to know advanced level topics. Only basic to intermediate level topics is good enough. I would say 10th class, 11th, 12th, high school level. Until high school level, intermediate level, if you are aware of those concepts and if you can quickly revise those, then it is good enough, right? The first pillar is math, and I will go in detail what are the different topics in math that you should be good at. For example, probability, calculus, and statistics also you can consider. Sometimes you can consider it outside math. Then you have linear algebra. So there are few topics that you should be good at. I will go in detail after I explain all of the 4 pillars. First one is math. Second one is coding or basic code. It could be Python or Java, anything, any programming language, right? You should be aware of the syntax. You should have that little bit of experience to code, right? Given an array or given a string, can you reverse the string using Python or Java, whatever programming language it is? Can you write the logic? Can you write the logic to get the task done? Right? That is important. So that is the second pillar. First one is good in math and have the basic understanding foundations of math, all of these. Second one is good in coding, decent average to above average in coding. Initially above average is enough. Later on with experience, you will go to advanced level in coding. Okay, so this is second one. Third one is the models, right? ML models or concepts, right? So see this one and this one. See, mathematics is like the foundation to understand machine learning models. There are so many machine learning models, for example, linear regression, decision tree, random forest, KNN. What are these? These are a certain model or algorithm, right, which has the potential to learn patterns from the data given. From learning the pattern, it can predict the future, right? So we need to understand, how does linear regression work? In what way is it learning the pattern present in the past data, and how is it predicting? Right, and decision tree, random forest, KNN, like this, there would be, I would say, around 15 plus important models that you should be aware of. That's it. Only 15 plus basic to intermediate level. For basic to intermediate level data science or machine learning, 15 plus approximately models will be there, like linear regression, decision tree, KNN, XGBoost, random forest, SVM, and so on. If you know all those, then good. You have covered third pillar also. Now, what is the fourth pillar? Application, right? Application. So you know the machine learning models. You understood the concepts, you know the math, you're good at coding. Given a use case, can you apply, let's say, a decision tree model on the data and then predict the future? Right? Can you identify the patterns and using that predict the future? So this is the last but very, very important one. Okay, application.
Yeah. Yeah.
Okay. I think there is a small disturbance. Let me see if I can mute everyone. All right. Okay, so let's come back, guys. All right. Okay, so these are the four foundational pillars. If you're good at these four, you can crack almost any interview. Many interviews you can crack. You can enter into the company and you can also excel in the company, right? Excel in many projects. You can get a lot of recognition, and your productivity will also will increase. You have to be good at all these four. Any one you're not good, then your basics are not good, you will struggle. For example, you're not good at coding, then you are good at application, you know the models mathematically great, but maybe you cannot write the code immediately and give the results on time. But you can get the support of internet and ChatGPT nowadays, that's totally fine. But without that, you should be good at coding, at least basic to intermediate level. At least basic to intermediate level, you should be good at. And you are not aware of models. You are very good at coding, you are very good at math, but you are not aware of these models. Yes, you have to sit and learn, then you may know it. But as of now, you don't know these models still. Then you will struggle to apply those in any use case, and you will definitely struggle to fulfill the requirement. So you have to be good at all the four. When you're good at all the four, that's when you can go to learn the advanced concepts. What are these advanced concepts? That is related to deep learning. Okay, so I would say neural network based models such as CNN, RNN, LSTM, GRUs, plus also nowadays LLMs, large language models such as BERT, and GPT, Llama. There are so many models. You need not know the mathematical background of GPT or Llama. That's not required. But you should know the neural network models such as CNN, RNN, LSTM, GRU. These are the core important models with respect to neural network architecture. So this is very important to know. So this is what I would say with respect to the basic. What are the skills you should have? These are the list of skills that you should have. Now let me explain little bit more in terms of each of this. For example, in math, right? I told you that it is important to know only certain topics. For example, probability. Now, I don't want you to learn the complete probability and start learning advanced concepts of probability. That's totally not required. What is required is only until 12th grade, right? Whatever basic concepts you know. And even in that, I would say additive theorem, multiplicative theorem. And this is very easy. But in our classes, I will give problems and examples through which we will understand what is this additive theorem and multiplicative theorem, which is very easy. Then we should understand what is independent event and what is dependent event, independent and dependent events, and how to approach during each of these events. Then we can understand conditional probability, Bayes theorem, very important, very important Bayes theorem. All right. Then a few other concepts such as joint distribution, stochastic nature. These are the most important topics with respect to probability, right? That's it. And it will hardly take, I would say, 3 to 4 hours to understand all of these. Hardly, probably maximum 6 hours if you want to solve problems, right, in each of these to understand the concept properly, right? Next would be linear algebra. And this is a very vast topic, guys. Linear algebra is a very vast topic, but again, to begin your career as a data scientist, you need not know all of the concepts in linear algebra. The core concepts in linear algebra that you should know are what are vectors, what are matrices, and some basic matrix, matrix nature of matrices, that is formulas or nature of matrices. For example, what is a determinant? How do you multiply or do dot product of two matrices? What is inverse of a matrix, right? And what is a square matrix? So all these basic transpose of a matrix, just basic understanding of these. You need not solve any problems by taking matrices, but if you understand all these, what is a determinant, the meaning of a determinant, how do you perform a dot product between two matrices, then it is good enough. Next, we can look at how do I deal with system of linear equations. That is, given n equations and n unknowns, using matrix, how can I find the value for these n unknowns using matrix manipulations? Right, using matrix manipulations. If you look at 3 or 4 examples, that is good enough. That is absolutely good enough. Then matrix factorization, which is specifically very much used in recommendation systems. Then linear transformations, very important. Linear transformations, also about eigenvectors. Right? Both are related concepts. So this is with respect to linear algebra. Now with respect to calculus. Calculus, we should understand what is integration, what is differentiation or derivative, and what is partial differentiation. This is very important to understand. And a little bit about limits, right? Initially, we will start with limits actually, and then we'll understand these topics, limits, functions, okay? Multivariate calculus, and few examples, applications of all of these. Apart from this, it is very useful if you know things about coordinate geometry and little bit about geometry. Then about optimization. Optimization. So under optimization, there is a linear programming optimization and non-linear programming optimization. So these might look, the terms might look very difficult and complex, but trust me, these are very simple. And throughout the classes, I will simplify the concepts, right? I will present a situation and I will tell what has to be found, minimum or maximum. And based on the situation, we can further break it down and try to understand how these optimization algorithms are useful in navigating towards the solution, the best solution, right? And for example, gradient descent is a very famous and most important optimization algorithm that we will use across many machine learning models. Many machine learning models, from linear regression model, very simple linear regression model, to complex neural network models. Gradient descent algorithm is like vastly used, heavily used, and there are also different types of gradient descent algorithm. Plus we have Newton's method, Lagrange's method. This is used in SVM model, but the whole point of me trying to mention each of these points is to let you know that these are the core topics for you to get well in mathematics. It's not like you have to pick up a big thick book and then start learning that and then start solving problems, and after 3 months you will be there finishing the mathematics part. It's not like that. It is only these topics that you need to know in probability, right? In linear algebra, in calculus, in optimization, and for which I will be giving you a lot of questions and examples and also conceptual breakdown, because of which your mathematical part will become very strong. Your foundation, at least the foundation part of mathematics, will become very strong. Using this foundation, you can understand the machine learning models. For example, if when we finish this gradient descent algorithm, so let's say gradient descent algorithm, which is a topic under math, right? Optimization algorithm. When you know this, with the help of this, you can understand linear regression model. Right, so this is the base. And since you know this, you understood linear regression model. Now, since you understood linear regression model, you will understand basic neural network model, that is a perceptron model. Okay. Now, since you understood this perceptron model, you can understand a complex neural network model such as RNN or LSTM. And from this, you can understand a transformers model. And from this, you can understand an LLM model. So this is how you can grow step by step, right? So when this is very clear, you can see how useful this is, because this is used here. This is also used here. This is also used here. And this is also used over here and over here. So when you hit this, it's like you're hitting, 5 different fruits with just one stone. Right. So you learn this and you can learn advanced models very quickly and easily. So that is the whole point of understanding mathematics properly. Now, I also told that the second pillar is coding. Right. Now, when I say coding, what does it mean? So should you spend months and months to get perfect in Java or Python? It's not like that. So the second pillar, coding, some very basic concepts you should know with respect to coding. So for example, what is the difference between OOPS versus structured? You should know this. You can pick any programming language like Python or Java, and you should know the basic syntax of that programming language, which comes with practice. Right? You have to go through the documentation, try to write code, get bugs, solve it, and then again repeat the process, and automatically you will understand the syntax. This is a conceptual part, which again you should understand this. Next, you should understand what are functions, right? And what is a class, object, which comes under OOPS, right? Functions also. Then you should understand basic things, basic programming flow charts or flow structures. For example, for loop, while loop, if else condition. Okay, so this is very important. These are very important. And you should be aware of basic data structures or collections, which are, you have arrays, right? You have lists, you have tuples, and this is in Python, by the way. And all of the coding we will be doing, majority of the coding we'll be doing in Python, because Python has a lot of frameworks and libraries ready-made code available for data science projects. So using Python really helps a lot, and most of the industry uses Python. 70 to 80% of the industry uses Python. Somewhere R and Java is used. Even Spark, PySpark, that too. Spark is used when the data is very large, big data. You're dealing with big data, right? So that's when Spark is used to deal with big size of data and take help of multiprocessing to execute things much faster. And when I say collections and data structures, these are the ones that you should know: arrays, list, tuples, sometimes strings, and dictionary, and few other collections. These are most important ones. So you should create an array and then try to play around with it. You should create a list and try to play around with it, delete some items, add some items, modify some items. Those should be very easily done by you. It should be done very easily. Then would come data science related libraries, data science or machine learning related libraries, which are NumPy, okay, and SciPy, Pandas, Matplotlib. This is for visualization. Seaborn, again for visualization. sklearn, that is scikit-learn. This is where different machine learning models are available. And then you can also try TensorFlow, Keras. These are advanced libraries useful for building neural network models. So neural network model is basically an advanced model, right? So initial 15 models that I told you are basic to intermediate models. All other models which are beginning from neural network are advanced, and for that you have these libraries: TensorFlow, Keras, you have CV, you have Spacey. In Spacey you have models related to text data, right? NLTK. So all these are different libraries, and it's not needed to excel in each and everything, but the most important piece of code in every library, you should be able to write it. You should be able to do it. So these are the important things you should be able to do with respect to coding, right? Of course, it also involves testing. Whatever you have written, you should be able to test the code and then try to um, fix the bugs, fix bugs and everything. Or this is also part of general coding. So this is the second pillar. Now third pillar, like I said, deals with machine learning models. So I will just jot down some models. If you're not aware of this, it's okay. But at least you would be aware now what are these terms called, what are the name of certain models that you should be completely have good clarity in. If you already know, then it is great. Some of models you might not know. So I will just write those down, and it will give you an awareness of what are the list of models that you should be aware to reach to intermediate level. So first one is linear regression. That's the very first model that we will begin with. It's the oldest model of all, and the first model we'll begin with is linear regression, then logistic regression, and then I have decision tree, and then random forest, and naive Bayes, right? And support vector machines, SVM. Then I have K nearest neighbor model. All right. I have K means model, K medoids, spectral clustering. Okay, hierarchical clustering, collaborative filtering, PCA, principal component analysis, SVD, that is singular value decomposition, which involves matrix factorization technique internally. This involves eigenvector, that is linear algebra technique. So every model, every machine learning model involves some mathematics behind, right? Where all of these points that I have written down, one of these concepts is used in these models somewhere. Okay. After SVD, I think I can write support vector machine. Yes, XGBoost, gradient boosting machine, CAD boost, right? And there are a few variations here and there. And I would say perceptron model or a basic neural network model. So these are the list of models that you should be aware of, right? And then you can call yourself that you are at intermediate level data scientist, right? Or in data science field or machine learning field. Okay. For advanced, it will be extension of these CNN, RNN, LSTM. CNN is to deal with images data. RNN and GRU, LSTM is used to deal with text data, but you can work on images also. Even for CNN, you can work on text data also. That's no problem. But it is custom made for images data, right? So the data can be of any form. The data can be present in a table like this, right? Or the data can be an image, right? Or the data can be a video, audio, right? Or data can have a text, anything, right? Usually when the data is in table, for example, I have here salary that can be predicted based on experience, based on test score, based on age. So based on these three inputs, salary will be decided. So you have all numerical data over here. In such cases, whenever you have a tabular data, tabular data, that is when all these basic to intermediate models will work very well. But when your data is of images or text or video or audio, then these intermediate models will not work well. Right. There are some exceptions. For example, XGBoost can work sometimes very well. Random forest also can work, but these models are not custom made for these kinds of data. That's where we have RNN, LSTM, GRU, and large language models. So I hope you guys are aware of some large language models like GPT, right? Bard, right? And Llama, DALI, right? So some large language models you should be aware of, and definitely I'll be explaining these topics also throughout the course, right? But that will be towards the end in the advanced part. So in the third pillar, right? In the third pillar, these 15 plus models, if you know, it is good enough. And it is very easy to know all of these, right? We will learn all of these and also implement this practically in Python. So fourth one is application. That is, you solve as many use cases as possible. As many use cases, for example, anomaly detection, right? And battery failure detection, okay? And recommend products to customers based on their purchase pattern and behavior pattern. Solve as many use cases as possible. Solve 10 plus and have at least 3 that you can project in your GitHub. Right, at least 3 you can project in your GitHub. Ideally, one should be in the neural network application. Another one should be using tabular data, and another one have a project where you have used images or text. I would say try to work on text data, because there's a lot of um, scope and opportunities coming up around generative AI side, that is using the text data side. So have at least 3 very good projects that you can put in GitHub. Right? So when you do all of these and when you start attending interviews after all the course is done, then definitely 100% you will be able to crack so many interviews and also excel wherever you're working. But that will not be over, because learning is continuous. Whatever I told you so far about the skills, that is only for intermediate level, right? Once you are at that stage, that's when you can go to the next level, neural network models, deep learning, LLMs, and so on, generative AI, and so on. So this is the first part. And second one, this is also something which I quite often this is something which I get as a question. What are the differences between all of these? Are they same or they're different? Yes, they are same. I mean, not exactly same. There are similarities. There are also differences, right? So the very first thing that you should understand, about AI, look at this term. It says artificial intelligence, right? Artificial intelligence. So we are humans. We have natural intelligence. That could be one term that we can use. We have intelligence by nature, right? Now I want a machine to be also having similar capability as humans have. When that is done, then we can call this machine to possess artificial intelligence, right? So in short, the entire field of AI is to mimic human brain. This is what is the entire field all about. Artificial intelligence is that field trying to mimic human brain using different strategies, techniques, different approaches, right? So it is a very, 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 very broad field. Broad, vast, big, whatever you call it. It's a very broad field. Okay. The reason I'm saying it as a very broad field is because just think about what are all the different things that a human brain can do. So I want a machine which can mimic human brain, isn't it? So what are the different things that human brain can do? We can understand logic, we can analyze, right? We have emotions, right? And we can solve problems. Okay. We understand language. Are we good at identifying patterns? Yes, I think we can identify patterns. Some can identify patterns much better than others, but overall, we all can identify patterns, right? And what else? We have creative process. We can be creative. So all are different things that a human brain can do, right? So is there any machine right now that exists which can do all of these things that a human brain can do? Maybe yes or no, that is debatable. There are some Japanese robots or AI that are there, in Chinese and even in US they are there, but nobody can call that to a level where it has reached, to compete with humans in all of the aspects, right? It is lacking in one or few aspects, right? So when a robot or a machine, when a machine comes up which can do almost anything that a human brain can do, then that is when we call that as an AI machine, or we call it as broad AI. Broad AI, which means it is capable of doing many things that human brain can do, many things. So now if I take an example of iPhone Siri, right? iPhone Siri. What are the different things that Siri in iPhone has the capabilities? It can understand language, isn't it? It can understand English, and it can also understand logic to decent level. It can analyze because it answers back to you. If you ask a question, it answers back to you, right? By analyzing, understanding, and then replying back again in the same language. It can also crack jokes. If you are aware, it can crack jokes. So that comes under creative process. So Siri can crack jokes. So it comes under creative process. So yes, Siri has some potentials that humans have, but it cannot do everything that a human being can do. So you can consider this as broad AI because it has many capabilities like creativity, language, logic, analysis, many things it can do. It might not have emotions. Definitely, Siri doesn't have emotions. It can project as if it has, but it doesn't have. Right? As of now, it doesn't have. So yes, some things it has, so we can consider it as broad AI. Now, for example, you have built a model, right, which can predict what is the Microsoft stock by August end. You have built a model. You as a data scientist have built a model, and that model is present inside a computer, right? This model is capable of predicting Microsoft stock towards the end of the August with a very good accuracy, right? Now, is this AI, right? Is this AI or not an AI? You can call it technically as an AI, but the actual term will be narrow AI. Narrow because it doesn't have all of the capabilities that a human brain has, right? It can only do one thing: predict stock price. That's it. By looking at patterns. It has seen the previous Microsoft pattern, okay? And using the pattern, it is able to predict. That's it, nothing else. It doesn't have a creative process, it doesn't have emotions, no analysis, nothing. It has only one thing. So it's called as narrow AI, right? So in short, AI is actually a very broad field. Like you can see here many things have to be accomplished to be called a machine as an AI, right? And the ultimate goal of AI is to mimic human brain. Now, to achieve this, multiple fields will come into place. For example, to come up with a machine which can understand patterns, you need mathematics support. You need stats, right? And to make a machine understand language, you need NLP, you need linguistics, right? What is linguistics? Linguistics is study of language, right? So only if I know the grammar structure of language, I can write the code in such a way that the computer can learn the language, right? So I need to know a little bit about linguistics, about cognitive science. Why cognitive science? Cognitive science is what? Study of structure of human brain. So there are different things in human brain, right? Memory part, short-term memory, long-term memory. There are different parts, frontal lobe, amygdala, different parts are capable of doing different things. So we have to study this to understand the basic nature of human brain to be able to replicate it using code, right? And make the machine have the similar abilities. So all these things should come together. All these fields should come together and try to make a big field called AI, right? Big system or a machine called AI. So I can say that AI, if I just go back, I can show the Venn diagram, which has all right. So here, yeah, you can see that AI is a broad field under which there is machine learning. And what is the use of machine learning? It is to learn pattern from the past data, right? Learn pattern from why is it important to learn pattern from the past data? Because only if I learn the patterns, I can use it to predict the future, right? So predict. So I want my AI to predict the future as accurately as possible by learning from the past data. And that is done by machine learning, right? Cognitive science, psychology, stats, math, robotics. Robotics is what? Robotics is just a machine which is automated to do certain tasks. And we will go in detail, each of these subfields will go in detail. I'll just give a broad overview to understand, right? Now, this is what AI, it's a very big field. It's an umbrella term under which there are subfields like this, okay? Now, I hope you have understood what is AI and what is machine learning. Machine learning is simply, like I said, giving the machine to ability to learn from the past data. Learning ability, right? Learning. And by the way, learning is also one ability that human brain has, right? And I forgot to add that in the previous here. So here, what I mean is that learning is also an ability. Mm, all right. So let's come back here. Okay, so machine learning gives the machine the ability to learn. Data science, then what is data science? Just look at the term. Let's break the term. Data science, which means I'm applying some science on the data, right? Some kind of science. What kind of science? It can be basic math like linear algebra. It can be stats. It can be machine learning also. Machine learning is one way to learn from the data, right? And why am I applying some science on the data? To find patterns and use that to predict the future, right? So data science is a field which internally has machine learning. And it also has data analysis. Data analysis, right? When I say data analysis, it is just find patterns. Data analysis is just finding patterns. When I use the pattern and predict something about the future, that is called as data science, right? That field is called as data science. So the basic core difference, data analysis, is just to find patterns from the past data, right? For example, it has found that females are 70% of the customers. 70% of the revenue come from females. From males, only 30% of the revenue comes. Is this a prediction about future? No, it is a pattern which was found by looking at the previous 2 years sales, let's say, right? It was a pattern that was found. How can this be found? It can be found using SQL query, or it can be found using graphs, charts, bar chart, multiple ways. Some pattern is found. Now, using this pattern, I want to predict something about the future. So that's where data science comes. Now, I may apply a model that, so here I have the data, right? From the data, I found this pattern. There can be many patterns. This is only one pattern I found. There can be many such patterns. For example, UK contributes 90% of the sales. Germany contributes 5% of the sales. Some patterns like that, right? And in India, let's say New Delhi contributes 60% of the sales. Some patterns you have found, which is very useful for business, great. But I want to predict the future. Next year, who will be the most contributing, which will be the most contributing country and which will be the most contributing city. For that, I may build a model. Let's say I may build KNN model, for example, and I will make the model look at the data and understand pattern and predict the future. Whenever there is something happening with respect to predicting the future, that is when I call it as data science or machine learning, right? So when I already have data science, why do I have this term called machine learning? Because using statistics also I can predict the future. Right? There is a basic difference between statistical approach and machine learning approach. In statistics, there will be many assumptions. In machine learning, few assumptions. That's quickest difference I can tell. In statistics, there will be many assumptions about the data. In machine learning, few assumptions about the data will be there. Okay, basic difference. So I may build a machine learning model, or I may build a statistical model, right? Combined, I can just call it as a data science. So here, this is called as data science. I have ML, stats, and data analysis. So this is what is the graph Venn diagram for data science in general. Now, I also have sometimes text data. So when I have text data, there is this field called natural language processing, which can deal with text data, all of the models. Similarly, I have one more field called computer vision that deals with image data, And I also have one more field called deep learning. That is a subset of machine learning. So like I told you, machine learning has around 15 models, isn't it? These are intermediate models, 15 plus models, basic to intermediate. But apart from this, there are advanced models also. Those are deep learning. Those are neural network based deep learning models. Okay. So finally, let me once again draw this Venn diagram. So I can tell this is for data science. Over here, I will have data analysis, where the idea is to just find patterns. And using machine learning, I can predict, right? Using stats also, I can predict the future. Under machine learning, I'm telling that I have a certain set of models called deep learning models, which are neural network based. These are advanced models. All these are basic models. Around 15 plus 20 approximately will be there. Then I also have something called NLP field and computer vision field, which are for images and text data. So in short, this is what is about difference between data science, data analysis. NLP is capable of dealing with text data. Computer vision is capable of dealing with images data. And deep learning is nothing but advanced ML models. Okay. This is to predict future. This is to find patterns. All right. Now, I hope you also understood the difference between AI and data science. So I think you can easily tell that AI is the major field. For example, I will put all of these under inside AI. Inside AI, I will have data science. I will also have cognitive science. But we are definitely not learning any much about this, but I'm just giving you an understanding. So we also have robotics, right? We also have linguistics, many things. Now, I am telling you that for you to be an intermediate data scientist, you need to have 4 pillars. You need to be good in these 4 pillars, which are these: Python coding or any coding. Python is the best. Mathematics, coding, machine learning, basic to intermediate models, and application. That's it. So this is what, in short, what I wanted to explain, and I made sure that I went on a very high level, brief overview. But I hope this answers many of your questions and confusions, and it actually intrigues you and interests you to start the data science journey, because trust me, it will be a very wonderful journey. You will enjoy the process. You will enjoy the mathematics, you will enjoy the application models, you will start learning about different other aspects also, like how human brain is, how we think, what are the future scopes, what are the future market, how every domain, finance, marketing, every domain will ultimately have AI, somehow merged into it, and how it will become inevitable. Definitely you will have to learn all of these things. So slowly and steadily you will understand all of these things. So let me stop right now at this point. So these are the main important points that I wanted to talk about. So I'm done. Let me see if there are any questions from you guys. I'm leaving the session open now. If you guys have any questions about anything in general, personal, career, concepts, anything, you can ask me now. Thank you guys. You can ask me now. All right. So apart from all of these, in our curriculum, we will be covering mathematical part also, because I want you guys to be strong in mathematical foundation. That will make your intermediate level machine learning models understanding and journey much easier.
There are few people who's asking that what is the duration, like on how many hours we supposed to deliver in this particular batch. Just a clarity that how many hours and all.
Definitely. Got it, understood. So, see, I would say including Python code, it would take around, I would say 70 to 75 hours, right? Including Python. But if I ignore Python, both stats and machine learning to intermediate level can be done in 60 plus hours, approximately 60 hours. Yes. Plus the 60 hours, I mean only the duration of the classes. Apart from that, you have to put time for projects and assignments and practice and revisions and everything. You have to put that separate time. I would say another more around 70 to 80 hours, you'd have to put, and that would take time because coding would take time. So overall 130 to 150 hours, including your personal efforts. And if you do that, you would reach to very good position. Yes. So regarding cost and everything, the admin team, the appropriate team will communicate with you. Once I'm done, these guys will inform you that. Okay. So if no further questions, then I think you can take over. Gaurav, I think you can take over. Or is there anything that let's see, is there
Thanks,
anything?
Manikant. So thanks for
Okay.
the session, and I'll just introduce the day and time that when we are going to start with the students, and we'll continue. Okay.
Sure. So I'll exit
Thanks for
for
the.
the session now. Thank you.
Yeah.
Thank you guys. Bye everyone. Thank you.